So hi there, welcome back to my channel. In this video, I'll be taking you through the decimal to binary conversion, the decomposition method. In our previous lesson, we learned about how to convert from binary to decimal. So we're doing the otherwise in this, but this is one particular type of approach we can use to do that. So this is the decomposition method. So let's see how we solve this. I have some three problems here. So when you say the decomposition method, it's a direct reverse for the binary to decimal. So you know that binary to decimal, what do? We multiply what? Each bit by what? Each bit by the significance. So let me say each bit by 2 raised to the power significance. But in this manner, we are going to decompose our decimal value into what? Powers of what? 2. So that we can reverse the direct process. Okay. So the powers of 2, what are they? 2 to the power 0, 2 to the power 1, 2 to the power what? 2, 2 to the power what? 4, 2 to the power what? Let's say 6, right? Then 2 to the power, you have 2 to the power 3 in that manner, 2 to the power 5. So these are the powers of 0. So this is giving me what? 1, 2, this is giving me 4, this is giving me 8 here. I have 16, I have this to be what? 64. 32, right? So if you have any given number, you can decompose the number into what? The sum of these, and after you can convert them easily to what? Our binary, right? So let's take the first one, A. I have 45. So 45 base 10. If I decompose this, what do I get? So we know that I have 1, I have 2, I have 4, I have 16, 64, 8, and 32. So no matter the level you take or any powers you take, you should get the same thing at last. So you first tackle the highest power, then you be coming gradually down, gradually down. Okay, so realize that the highest power we can go, 2 to the power 5 is 32, and this number is less than 32. If you're going to take 2 to the power 6, that will be 64, which is greater than 45, so it's not feasible. So the highest you can take is 2 to the power 5. So simply write 2 to the power 5, or simply let's use the 32 itself so that we can know where we are going. So you simply write 32 plus. So 32 from this, what are you left with? You are left with 13. 13, right? So from 13, what highest power can amount to 13? You realize that 4, 2 to the power 4 gives us 16. It's greater than this, so we can't use that. 2 to the power 3 is the next, which is 8. So plus 8, right? So now you have added 8 to it, you are getting 40. So remember what? 5. What highest power can we get 5 from? 2 to the power of 2. So that is 44, right? Then now we'll be left with 1. So 1 is obviously what? 2 to the power of 0, right? So from here, just write 2 to the power 5 plus 2 to the power 3 plus 2 to the power 2 plus 2 to the power of 0. Okay, yes. So once you have this, the next thing to do is, you know that the significance should follow 0, 1, 2, 3, 4, 5. You get it? 0, 1, 2, 3, 4. So when we don't have the significance here, it means that that portion is 0. So when I start here, at my 0 significance, I have 1. The next one is what? 1. For the 1, I don't have anything here, right? So meaning it's 0. At the 2, I have what? I have another 1. So I replace it with what? A significant what? Bit, or I replace it with 1. Then I have 3. So 3 is going to be 1. Then there's no 4. So 4 will be replaced with 0. Then 5 will be replaced with 1. So this becomes our binary conversion. So it is what? 1 0 1 1 0 1 base 2. Okay. So let's see the second one, 76. So for the 76b, 76 base 10, you know that this is going to give us what's the highest power? That's what you ask yourself. The highest power that you can get 76 is 64, which is 2 to the power 6. So you simply write your 64 down plus. When you subtract 64 from this, what are we left with? We are left with what? 12. 12, simply 12, right? Or 12 plus 64 give us 76. What's the highest power that you can get 12? That is 2 to the power what? 3, right? And that is 8. Then after that, we'll be left with 4. You know that 4 is 2 to the power what? 2, right? Which is 4. So let me write 4 here. Okay. So let me write my 4 here. So this is plus 4. So 4 plus 8, 12 plus this 76. That's all. So this is same as 2 to the power 5. No, 6 plus 2 to the power 3 plus 2 to the power 2. Okay. So with this, if you want to write a binary, you know that the binary should start from 0 to 6. That's the interval. So when I start 0, there is no 0, meaning it's 0. There is no 1, meaning it's 0. Then there is what? 2, so meaning it's 1. Then there is 3, meaning 1. There is no 4, 0. There is no 5, 0. Then there is 6, is what? 1. That's all. So this becomes 1001100 base 2, right? Then what's the last one? The last one in our sets is 25, okay? Yeah, 25 base 10. So what is 25 base 10? 25 base 10. So this one to ask yourself, what's the highest power of 2 that can give at 25? Okay, you know that 25 you can only have 16, right? 2 to the power of 4, right? So 16. Then after 16 from here, you get what? 9. Is that not it? So 9 to you have plus 8. Then 8 you'll be getting what's remainder 1. And remainder 1 is 2 to the power of 0, right? So 1. So this is the same as 2 to the power 4 plus 2 to the power 3, 2 to the power 0. So as you are writing this, our zero significance, so it's 0 to 4, right? 0 to 4. So 0 is what? 1, because there is 2 here. Then the next one is 1. There is no 1, so meaning it's 0, right? Then there is no 2, so that's 0, right? Then there's 0, 1. There is 4, 1. So we are getting 11001 base 2. Thank you for being with me in this video. Don't forget to like, subscribe, and share.